students, welcome back to my channel once again. So today I'll be discussing the CBSE Board Grade 9. The chapter is quadrilaterals. So in the previous video we have discussed what do you mean by quadrilateral and different type of quadrilaterals like parallelogram, rectangle, square, rhombus and kite. And also we discussed the properties of the quadrilateral, different types of quadrilateral, right? So now in this lecture you will see different type of problems, how to solve these problems. Okay, so let's dive into it. The first question is, show that the diagonals of a square are equal and bisect each other at right angles. Right angles means 90-degree angles, right? So let's take a look what we need to um, prove over here. So here we need to prove the diagonals of the square are equal and their bisecting means they are equally dividing each other at right angles means that is perpendicular, right? So in this case, what do we need to prove? That is, we need to prove that AC and BD are the diagonals over here. So AC and BD is equal, right? And then they bisect each other means, since we can see clearly that AC and BD they intersect at point O. So bisect in each other means OA equal to OC. Okay, so O will be the midpoint of AC and similarly O will be the midpoint of BD means OB equal to OD. And also we need to prove that they are making the right angles means OC is perpendicular to AD, or we can say that AC is perpendicular to BD. Okay, these things we need to prove. Now let's take a look how we are going to prove it. So let's now do the proof over here. Okay. So now the first thing we need to prove is AC equal to BD. Okay. So now for proving sides congruent, prove that triangles are congruent. So for side BD, consider triangle DAB. So this is the triangle DAB. For side AC, consider triangle CBA. Okay. So we need to prove that these two triangles are congruent. So let's take a look. In triangle DAB and in triangle CBA. Okay. So what are given? AB is the common line. So AB equal to AB. That is the common side. Now, since it is a square, so you already know that in square all angles are 90-degree. So, angle DAB equal to angle CBA, that is each is 90-degree. And we also know that in a square all sides are equal. That means AD is equal to CB, right? Or you can say AD is equal to BC. So, sides of the squares are equal. So, that means triangle DAB is congruent to triangle CBA by which criteria? That is the SAS, because we can clearly see that two sides and the included angle in between angle of two sides are equal. So that's why we can apply the SAS criteria over here. Okay. Now bicepticity means congruent parts of corresponding triangle. So by CPCT we can say that AC is equal to BD. So this is the first proof. So that we have proved already. Now we need to prove that OA equal to OC and OB equal to OD. So for proving sides congruent, let's prove the triangles congruent. Okay. So in this case, let's take a look what are the sides over here. Okay, so these are the sides. First we need to identify the sides. Then we can identify what will be the triangles that is forming those sides. So in this case, we will consider the triangle AOB and triangle COD. Okay, it's already highlighted which triangles we are talking. Now in triangle AOB and triangle COD, let us check which are common over here, which are equal. So we can clearly see that AB is equal to DC. right? And another thing, since it is a square, means the opposite sides are parallel also. So that means AB is parallel to DC. So we can clearly, and here we can see that AC is the transversal line. So we know that if there are two parallel lines and there is a transversal line, then the alternate interior angles are always equal. So in this case, the alternate interior angle are DCO, right, and angle OAB. These are alternate interior angle. So these will be equal. Okay, and also AB is equal to CD, correct? So because sides of the square. Now we also know, similarly we can also prove that since AB is parallel to CD, okay, and BD is also the transversal line, so angle CDO is equal to angle OBA. Okay, these are also alternate interior angles, so this is also going to be equal. So here we can apply that ASA criteria. ASA means angle side angle. So whenever two angles and the common side between the two angles will be equal, then we can say that using the ASA criteria, these two triangles will be congruent. So triangle AOB is congruent to triangle AOD. Okay. So now, according to CPCT, that is corresponding parts of congruent triangle, we can clearly say that OA is equal to OC, correct? And similarly, also by applying the CPCT, that OB equal to OD. Okay, so this is the second proof that we have already proved now. Now, the third proof, that is AC is perpendicular to BD. These things we need to prove. Now, in this case, which triangles we have to consider? Let's now consider triangle AOD and triangle COD. Okay, so let's highlight that AOD and triangle COD. Okay, so the adjacent two triangles. So in triangle AOD and triangle COD, AD is equal to CD because we know that in square all the sides are equal, correct? Now we already proved that OA equal to OC, that is by CPCT we already proved that. Okay, so OA equal to OC. And another thing we already proved earlier, means not proved, means the common side. OD. If you take a look, since these are the two adjacent triangles, so OD is the common side over here. So OD equal to OD, that is the common side. Okay. So in this case, by using S criteria, that is side criteria, we can clearly say that triangle AOD is congruent to triangle COD. Correct? So in this case, what will happen? That angle AOD equal to angle COD. Okay, by using the CPCT. So, but these are what type of angles? These are linear pairs. So that means angle AOD plus angle COD equal to 180 degree. Correct? Now replace one angle with the equation 2, that is angle AOD plus instead of angle COD we can write angle AOD because these are two equal angles, so that is equal to 180 degree. So that means 2 angle AOD is equal to 180, so angle AOD will be 90 degree. So hence we can clearly prove that AC is perpendicular to BD because it is making a 90 degree angle. Hope this is clear to you. Now coming to the next problem. Okay. Diagonal AC of a parallelogram that bisects angle A. Okay. Show that it bisects angle C also, and ABCD is a rhombus. So what is given? That a parallelogram ABCD where the diagonal AC is given. So it bisects angle A, and we we have to show, so it is given. Okay. What we need to prove? That we need to prove that it also bisects angle C and ABCD is a rhombus. So that type of parallelogram will now become the rhombus. Okay. So let's take a look how to prove it. So the parallelogram ABCD, let us draw the parallelogram first. Okay, so this is ABCD parallelogram. So what is given? That diagonal AC bisects angle A. So AC is dividing angle A into two equal angles. So that means angle DAC equal to angle BAC. So this is given. Okay. Now what we need to prove? We need to prove that it bisects angle C. So that means we need to prove that angle DCA is equal to angle ACB. Okay, so we need to prove that angle DCA is equal to angle BCA or ABC, ACB. Okay, whatever you name it. Now, if you let's check how to prove it. So we know that ABC is a parallelogram. So in parallelogram, what are the properties? In parallelogram, the properties are the opposite sides are always parallel. That's the definition of the parallelogram, right? So that means AD is parallel to BC, right? Okay. So now in this case, AD is parallel to BC and AC, what it is? It is the diagonal, but also with respect to parallel line, this is also the transversal line, isn't it? Because it intersect in two different points of the parallel lines. So as we know that alternate interior angles will be always equal because angle DAC is equal to angle ACB. These are two alternate angles. So angle DAC equal to angle BCA. So AD is parallel to BC and transversal AC. So angle DAC equal to angle BCA. Always whenever you are writing any angle equal, you need to write by which criteria or by which thing we can say that they are equal. So always mention that in bracket that this is alternate interior angles. Okay. Then comes your AB parallel to CD. Correct. And AC is the transversal over here. So angle BAC, okay, angle BAC will be equal to angle DCA. These are also alternate interior angles. Correct. So let's write that. Okay. Now what is given over here? That angle DAC is equal to angle BAC. Okay. So if you take a look that in these two equation number 2 and 3, angle DAC and equation 3, if we just check, this is angle BAC, those are two equal. Okay. So what we can say that angle BCA from the equation 2 will be equal to angle DCA from equation 3 because their common connection is angle DAC and angle BAC. Correct. So here what is angle BCA and angle DCA? They are just equal. So that means angle C is bisecting by whom? That line AC, right? And AC we know that is the diagonal. So what we have proved just now that AC bisect angle C. So we have just now proved the part 1. Okay, now let's take a look at the part 2. That is ABCD is a rhombus. So what we already got from the earlier one, that angle DAC equal to angle BAC. Correct? And angle DCA is equal to angle BAC. These we got from equation 1 and 3. Okay. Sorry. Okay. Now in triangle ADC. Now take a look at triangle ADC. In triangle ADC, angle DAC is equal to angle DCA. Why? Because we already know that angle DAC equal to angle BAC and angle DCA equal to angle BAC. So that means the common link between these two is angle BAC. So from equation 1 and 3 we can say that angle DAC equal to angle DCA. Correct? So that means if you take a look, so what happens now? Triangle ADC will become the isosceles triangle now, isn't it? Because angle DAC equal to angle DCA. So that means DA equal to DC, because we know that sides opposite to equal angles are always equal. Correct? So what we can prove over here, that DA equal to DC. So, but what is the criteria for rhombus? In rhombus, we know that rhombus is a special type of parallelogram where the adjacent sides are equal. Because if AD is equal to DC, then DC already according to the parallelogram property, DC is equal to AB, right? Similarly, AD is equal to BC. So that means all sides will be equal. So we can clearly say that ABCD is a rhombus. Okay. I hope this is clear to you. Now let's move to the next problem. So a parallelogram is a rhombus if one pair of adjacent sides are equal. So we can just, you don't need to prove for other sides. You can just clearly say that if one pair of adjacent sides are equal, then the parallelogram will become rhombus. Okay. Now let us take a look at this problem. So ABCD is a parallelogram. Okay. In this, and AP and CQ are perpendiculars from vertices A and C on diagonal BD respectively. Okay. So ABCD is a parallelogram and AP and CQ are the perpendiculars from the vertices A and C on the diagonal BD. What we need to show? We need to show that triangle APB, okay, triangle APB is congruent to triangle CQD. This is the part 1 we need to prove. Then in part 2 we need to prove AP is equal to CQ. Okay. So now let's take a look how we are going to prove it. So ABCD is a parallelogram given. So that means, and another information is given that AP and CQ are perpendicular. Okay. So let's draw the line. Yeah. So now we need to prove triangle APB is congruent to a triangle CQD. So now in triangle APB and triangle CQD, AB and CD, these are parallel lines and BD is the transversal, correct? Okay. And so we can see that since BD is a transversal, so that means the alternate interior angle CDB and angle DBA, these are alternate interior angles, or we can say that angle ABP is equal to angle CDQ. So this will be equal because of alternate interior angles. Now APB, correct, APB is equal to angle CQD because these are 90 degrees. This is given. Okay. And since AB, CD is a parallelogram, so AB is equal to CD because the opposite sides are always equal in parallelogram. Correct? So what we got, that triangle APB will be congruent to triangle CQD by AAS criteria, means angle side. So here if you take a look, the two angles are equal, correct? Two angles are equal and another side which is not common to the angle, that is equal. So that means here we need to apply AAS criteria, not AASA. In what is the difference between ASA and AAS criteria? In ASA, we have to consider the two angles and the common side between the two angles. That is the ASA criteria. And in AAS criteria, we have to consider the two angle and the non-common side of it. Okay. So this is the first proof we have already done. Now coming to the second proof, that AP is equal to CQ. So now, since we have already proved the triangles are congruent, so by using the CPCT, that is corresponding parts of congruent triangles, we can clearly say that AP is equal to CQ. Okay. So I hope this is clear to you. Now let's solve the next problem. In parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that BP is equal to BQ. So let's take a look at the figure. Show that triangle APD is congruent to triangle CQB. Second part is AP equal to CQ. Third part is, okay, so there are so many parts. So let us take a look one by one. Okay, so what are given? That 2 points are there, P and Q, on the diagonal BD, and what is given, that DP equal to BQ. This is given. And now, okay, so let's mark in the figure what are given. Now what we need to prove, that triangle APD is congruent to triangle CQD. So let us mark the triangles. So these are the two triangles that we need to prove are congruent. So now let's take a look how to prove it. So in triangle APD and triangle CQB, okay, what we have, we know that AD is equal to BC, because in a parallelogram opposite sides of the parallelogram are equal. Okay, AD is parallel to BC and BD is the transversal. So the alternate interior angles will be equal. Correct. So angle ADP is equal to angle CBQ, because they are alternate interior angles. Okay. And another thing is given, that is DP is equal to BQ. This is given. So we can clearly say that by using SAS means, I am reminding you once again, SAS means two sides will be equal and the included angle should be equal. Okay, then only we can apply the SAS criteria. So by using SAS criteria, triangle APD is congruent to triangle CQB. So the first part we have proved. Okay, now coming to the second part. So AP equal to CQ. So if you take a look, these are the corresponding part of the triangles that we just now proved. So by using the CPCT tool, we can clearly say that AP is equal to CQ. I know now you know the meaning of CPCT means corresponding parts of congruent triangles. So second part is also proved. Now coming to the third part. Here what we need to prove, triangle AQB is congruent to triangle CPD. So let's take a look at the triangles. Let's highlight it. Okay. So these two triangles are equal, that we congruent, that we need to prove. So AB is equal to CD, because the opposite sides of a parallelogram are equal. So in triangle APD and triangle CQB, we have AB equal to CD, that is opposite sides of a parallelogram are equal. Since AB is parallel to CD and BD is transversal, so the alternate interior angle will be equal. So angle ABD, or we can say angle ABQ, is equal to angle CDP, because alternate interior angles. And another thing is given, that is BQ equal to DP, that is given. So we can say that triangle AQB is congruent to triangle CPD by using the SAS criteria, right? Now, to prove the fourth one, that is AQ equal to CP. So this is, we can just now prove this by using the CPCT, because already we proved the triangles over here, correct? Now the fourth part we have already done. Now coming to the fifth one, APCQ. Okay, so APCQ is a parallelogram. So that we need to prove. Now to prove that, here we need to consider AP equal to, because that thing we already proved in part 2 and part 4, that AP equal to CQ and AQ equal to CP. This thing already we have proved earlier, right? Now just what we know, that a quadrilateral is parallelogram if the opposite sides are equal. So in APCQ, AP equal to CQ from equation 1 and AQ equal to CP from 2. So we can clearly say that APCQ is a parallelogram. Okay, hope this is clear to you. So a quadrilateral in which opposite sides are equal is a parallelogram by using that property. So whenever you are writing something, you have to write that by using which property we have concluded this. Okay, so always mention that thing. So that's all for today. I hope it is clear to you. So if you have any doubt, or if you have doubt not only in these problems, if you have doubt in other problems as well in quadrilateral chapter, you can post it in the comment section, and then I will try to come up with a video for that. Okay. If you like the video, please hit the like button and please share it with your friends so that they can also learn the quadrilateral chapter from the videos. So if you have not yet watched the previous videos, please watch it first, then come to this video. Otherwise, you will not be able to understand. Okay. So if you want to watch the further videos of the quadrilaterals or any other chapters that I'll be covering for the class 9, for that you need to do one thing. Just just click on the subscribe button. So for that you just need the once you click on the subscribe button, what you will get? You will get the notification whenever I will upload the future videos. Okay. So that's all for today. Bye bye.